This question comes from section 8-1. I know it's kind of hard to see the question, so I'll read it out loud in just a second here. But this question is asking us to find a test statistic. Now, the test statistic that we calculate depends on whether we're testing a claim about a population proportion, so proportion if the parameter is a proportion p, or if we're testing a claim about a population mean. So if the parameter is a mean mu, then depending on whether you know sigma, so if sigma is known, then we would use the sampling distribution that is a normal distribution. And so on the normal distribution, your test statistic is going to be a z-score. But if you're testing a claim about a mean and sigma is unknown, then we would approximate probabilities with the t-distribution. So your test statistic would be a t-score or a t-value, or we typically call it a t-statistic. In this particular problem, we're trying to test the claim that most adults would erase all of their personal information online if they could. So a software firm surveyed 507 randomly selected adults and showed that 60% of them would erase all of their personal information online if they could. So in this particular example, or this question, we're testing a claim about a population proportion, where the proportion represents the percentage of people who would erase all of their personal information online if they could. Okay, so even though this question does not ask us to write down the null and alternative hypothesis, let's go ahead and do that, okay? So in this particular problem, the claim is that most adults would erase all of their personal information. Most means more than 50%. So that will be the alternative hypothesis. So the alternative hypothesis is that P is greater than 0.50, because that means more most, right? Majority, more than 50%. And so the null hypothesis is going to be that P is equal to 0.50. So if the proportion is 50%, then that means that that's not most, okay? This implies that our null hypothesis value, P naught, is 0.50, and you'll need to know that when you're using the formula, and also if you use the calculator to get your test statistic. Okay, so what is a test statistic? A test statistic in this example is going to be a z-score, because we always use the normal distribution for our sampling distributions for sample proportions. And so the test statistic is going to be a z-score. It is a z-score for your sample statistic. So in this particular problem, we need to figure out what that sample statistic is. So to test the claim, we surveyed 507 people, so that's our sample size. And of the 507 people, our sample proportion, which is p hat, is that 60% of them said that they would erase their personal information online if they could. So p hat is 0.60. So what we want to do is we want to calculate the test statistic, or the corresponding z-score, for a sample proportion of 0.60. So on the standard normal distribution, so this is our sampling distribution of sample proportions. So just imagine that this distribution has a whole bunch of p hats in it, okay, right? So it's made up of a whole bunch of different sample proportions. Anytime you take a sample of 507 people and survey them, right, because it's a random sample, we could potentially get a different p hat every time we repeat this study. And so that creates this sampling distribution. On this sampling distribution, we will find that 0.50 is at the center. It's got a high probability of occurring, right? And we want to know, where does 0.60 fall in this distribution? So our p hat of 0.60, I know it's to the right of our p naught value, but how far to the right is it? Okay, so we want to know how far away is our sample proportion of 60%. So to figure out how far away it is, we try to convert that sample proportion to a z-score. And so we can put that z-score on this normal distribution here, where at the center, where p naught is 0.50, that has a z-score of 0. And then now we just need to figure out if our sample proportion has a z-score that would make it significantly high. So to do that, if you use the formula, the appropriate formula is z is equal to your p hat minus your null hypothesis value divide that by the square root of the null hypothesis value times 1 minus the null hypothesis value. And just off to the side here, sometimes we call that Q. So Q is just the complement of P. So whatever P is, Q is just 1 minus P, okay? And then we divide all of that by our sample size of N. So let's take all the information that we have and put it into this formula. I'm going to move to the right here because I need a little bit more space. So that z-score is going to be 0.60 minus 0.50. Divide that by the square root of 0.50, 1 minus 0.50, divide that by our sample size of 507, and that will give us approximately 4.50. So that is a pretty high z-score. It's more than 2, and we learned in earlier chapters that z-scores that are 2 or more away, or 2 or more away from the center, means that it's statistically significant. So here we would actually plot that z-score 4.50, which corresponds to, so I should really move this p-hat further to the right of this distribution.